What's up guys, welcome to my channel. In this video, I'm gonna show you a demo of my network project, Network Campus Simulator. I designed a network infrastructure for university campus using Cisco Packet Tracer. As you can see from the physical mode, I renamed the default city name as TRU Campus. If you click here, you can see the main 5 buildings on campus, such as Open Learning Center, House of Learning, Campus Activity Center, International Building, and Old Main. I connected them using routers which form like a pentagon because I thought it looks more organized. Before I explain the details, I'm gonna show you a testing phase first because I get you. I understand most of you are too busy to spend your time watching hundreds of candidates' portfolios. So let me show you really quick. First of all, suppose PC2 in the Open Learning Center, this guy, wants to start communication with Server 5 in the CAC building here. The routing table on router 0, this guy, has information about its directly connected networks like building 2 and 5. But it may not have information about the destination network, which is building 3, 192.168.30.0. The PC2 generates a packet addressed to the server 5 and forwards the packet to its default gateway at router 0. At the point, router 0 checks if its routing table has a specific entry of the network address of the designated building. It uses a routing information protocol to broadcast its routing information to neighboring routers, including router 3. Then, the router 0 broadcasts updated information of the networks. The router 3 receives this update, and it also updates its routing table accordingly. The packet reaches the router 3 in the CAC building, and the router 3 forwards the packet to the server 5. Once the server 5 receives the incoming packet from the router 3, it processes the request to reply with an acknowledgement to the source IP on the PC2, 192.168.10.2. The router 3 recognizes the shortest path to reach PC2 through the router 0 because its routing table already has this information. If there are any changes in the network, it might send the RIP updates to neighboring routers in order to inform them about its current routing table. The router 3 forwards the acknowledgement to the router 0 based on its update routing table. The router 0 directly forwards the acknowledgement to the PC2 because it already knows where to send it due to its routing table that already has this destination IP address, which is PC2. The acknowledgement packet finally reaches the PC2, which is the end of the complete transmission. And if you look at the status down below here, it's successful. Let me back to the physical mode. The data center is in the Open Learning Center. If you go investigate it, there are PCs on the table, router, switch, and a server in the rack. As you can see in the logical mode, to connect devices in each building, I used copper straight through cable type UTP, which is optimal for such a short distance and its low prices. On the other hand, between routers for inter-building connections, I used a multimode of fiber optic cable because it's optimal for long distances. As you can see 2 IP addresses on each router, I assign a specific IP address to each interface of the router for precise identification and seamless communication between routers. Now let me explain how I assign IP address. In order to ensure efficient IP management, I allocated a unique network address, subnet, and default gateway for each building. For example, the IP address of end devices in the Open Learning Center ends with tens, such as 192.168.10.2, 10.4, 10.3, as well as the default gateway ends with 10.1. In Building 2, the House of Learning, it ends with 20s, such as 192.168.20.3, 20.7, 20.6, and the default gateway ends with 20.1. And similarly, in Building 3, the CSE building, it ends with 30s, and so on. I chose devices strategically such that routers play a crucial role in interconnecting networks, switch facilitate local connectivity as central device in each building, and PCs and servers as end devices respond to the individual needs of each building. Each end device is also allocated an IP4 address. This device selection ensures a comprehensive and scalable network infrastructure. I implemented the routing information protocol on all routers because the RIP uses a distance vector algorithm to find the optimal path to reach the destination, like the lowest cost and shortest path. Each router is configured with the appropriate network addresses, ensuring dynamic routing capabilities and adaptabilities. I also configured a dynamic routing protocol for its simplicity and effectiveness in smaller networks. The reason why I chose the RIP in this scenario is that, like I said, the distance vector algorithm can determine the best path to the destination by itself. In this scenario, the distance vector offers some benefits where the network scale is moderate and simplicity is prioritized. As a future enhancement, I'm planning to configure firewalls for security purposes. So that's all about the demonstration and full details of my network project. I attached this packet file and the documentation file in the description box below in case of if you're interested. I also upload different videos about my other project as well, so please check them out. Thank you so much for watching till the end. I really appreciate your attention. Hoping you have a nice day.